Hey everybody, it's Larry. It's Saturday evening here in New York. I'm working on Leetcode Weekly Contest 174. Wish me good luck. Usually we'll need it. Uh, how's everyone doing tonight? Hope everyone's doing okay. Okay. Oh yeah, I just want to make sure I registered because sometimes I forgot. But yeah, um, make sure to hit the like button, hit the subscribe button, and hit all those things you like. Tell your friends, tell your enemies. I don't know. Just tell people. I'm kidding. I don't. Doesn't really matter. But cool. 5 seconds to go. Let's do this.
Breathe
All
in,
right.
breathe
All
out.
right. All right. Yeah. First problem. So yeah. So this seems like a pretty straightforward problem. It's just for every row, count the number of ones and then sort by the number of ones from fewest to the highest. But um, and type we can go to earlier index. I made that mistake a couple of times recently, so this time I definitely know to think a little bit better. Um, with the sorting last week, I think I had some issues, so this time I was definitely more deliberate about it. Um, yeah, I was trying to do this a little bit differently than I normally would. Maybe that was a bad mistake, to be honest. Some of that was that this week I have been a little bit sick during the week. Uh, I feel okay now, but thanks for wondering. But as a result, I didn't practice, or like just didn't do any coding at all this week. I'm a little bit rusty, and here the syntax is just bad. And uh, like in theory, I should have been almost done about a minute in, and I am almost a minute in, but I forgot the exact syntax for sorting, so that's kind of embarrassing, and also just waste of time. Oh man. Yeah, I mean, even now you see that I kind of wasted about 40 seconds just testing this. There's still one more thing I have to fix, but that was kind of the glaring part, unfortunately. Oops. Uh, and yeah, I mean, I'm just pointing out some like very obvious stuff. And even though like, 30, 40 seconds doesn't really matter in the grand scheme of things, in a lot of contests anyway. On lead code, it often means like a couple of ranks higher or lower, right? So that's something that, I mean, I'm not going to rush myself because getting the right answer is still the most important. Um, but it is something to think about when I think about optimizing my user story. And of course, I wanted to at least put in the second test, even though I'm kind of confident on this one, but I just want to be a little bit more confident considering I just couldn't even remember the syntax for sorting. So uh, cool, Q2. Um, yeah, this one, I don't like I think I had a couple of ideas thinking about it, but I knew that the first thing I wanted to do was put it in like some sort of data structure that allows me to count the number of digits because we only care about because the order doesn't matter. So we want to just count the number of numbers that and what it showed up, right? And actually, I don't think I thought about this at in the moment, but I also wanted to also quick note is I actually didn't need to do this. You could just put it in the array in the collection type counter. But I was like, okay, do you actually had a typo that I was like, actually, you don't really need the elements themselves, just the counts, right? So that's kind of essentially what I did. The rest of it is greedy. Um, yeah, the rest of it is greedy. You always want to remove the largest or the count with the largest number. So that's essentially what I did, and yeah. but just a lot of silly mistakes because I feel like now, mm, I mean, I think at this point, this particular case is not a silly mistake because I really wasn't sure where I want to go with it. I feel like intuitively it was greedy, but I think I was still trying to figure out how to convince myself that it is greedy a little bit. I mean, it's obvious now afterwards, um, but during the time I was like, "Are you sure, Larry?" And I'm just trying to think about it, think it through. I mean, I didn't. Oh yeah, I was debating using a queue so that we could pop off the front, but then I was like, oh no, just swap the other way and then pop off the back. So that's what I did. But because I use values instead of yeah, the other way. Um, I actually didn't need to index it, and that's where some of the error is. But that's not a big deal. I actually end up only spending about 3 minutes and a half or so in this problem, which of almost 4 minutes. But I think like I was legitimately thinking about this problem a little bit. Maybe I'm a little bit rusty about it, but so I wasn't really sweating the time. I actually thought I felt like I ended up doing it faster than not faster, but like while I was coding, I was like, wow, I'm doing it really slowly. But 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 it still only took 4 minutes, which is not fast, but it's not it's manageable speed, I think. Um, Everything looks okay. The only thing that I looked at the test cases that I didn't like was that 21115 is the test answers. I was like, maybe a little bit sketchy. We'll see. But it worked out, so I was good. I was also worried a little bit about off by one for the half exactly or not or something like that. But yeah, Q3. Yeah, tree problem. Um, I think so. This one is kind of interesting. I was thinking about how to do it the entire way. To be honest, I didn't really have a like. Usually, I know immediately what I want to do, um, but in this case, I actually didn't. And I saw that n is 50,000. Um, so I knew that I had to do something in linear time. I knew that n squared wasn't going to cut it. And I looked ahead just to see if this is easier. When I saw this, I knew it was going to be dynamic programming, like right at this moment. But I was like, okay, let's just finish the third one. It seems like it should be doable. There's a lot of, it feels like this one has some reading that I like to think about. So I didn't really want to get into it quite yet. Um, I wanted to give the tree problem just a few more minutes to marinate in my head before deciding. I guess I did end up spending more time here than I remember, to be honest. I think actually here I also thought that maybe some sort of breadth first search, but I misread that problem actually, which I'll talk about right after this. Um, so yeah, this one I'm thinking about it again. I'm like, okay, Larry, you could probably do this. Just do it. I think that's what I was like literally telling myself a little bit. I think I was still thinking about how to do it in one depth first search. Um, but I was like, a lot of things that like maybe cache to the left and then cache to the right and then do something funky with the current like given a node, you have the left sum and the right sum, and maybe we can do something around that and ancestor or something like that. but I was like, that seems like sketchy maybe. Um, but yeah, I'm still actually thinking about this one a bit. But I think at this point, I knew that the one thing that I wanted to do was uh, get the sum of the array, and then because I think the idea that I hit on about nowish was that there is like a partition of two parts. So if you get the sum, it's almost kind of similar to a prefix sum, where like, well, if you have if you have the sum of the entire piece and you divide, like you look at a number in the middle and you know that the sum of the prefix, then you also know the sum of the suffix, right? It's not quite that's not how quite it maps out, but that is kind of the same philosophy where leads me to my next point. Where like, okay, now I have the sum. I just need to get a second sum, which is the sum of all the subtrees, and then do essentially the same thing. But while I'm going there, um, yeah, while I'm going there, just keep track of the best. That's essentially what I end up doing, because the other, a very other common depth first search tree problem is just getting the sum of a subtree at every node, right? So that's essentially what I end up doing here. I did this one with kind of, in place sum versus the global sum, which I did even in the other one. And then that's pretty much it. I have some typos here that you can maybe spot out. But unfortunately, I ended up spending 5 more minutes on this, even though this is about 90% done. Some of it was typos, but also some of it server was being a bit slower than I would have hoped. I was like, okay, this is it. This is about 11 minutes in. I have about 5 minutes to submission or complete submission. Let me put in some test cases. Yeah. I think one thing that I did forget, but luckily that I remember because of all these cases. I was like 0, that doesn't make sense. Let me run again first. And it's really silly, to be honest. And I default to using print statements, but I think this is when oh, I forgot to return. That's why, which is also a bug that would have given a 0 answer. But this took a long time. Let's kind of see. I did this one or the subsequent ones, and I'm like spinning my fingers here, looking at Q4 a little bit. But I'm not one of those people who could like multitask different problems. So I don't know. I guess I was very close, but I didn't know how close I was. This is about 25 seconds in now, which is really sad. I'm just reading the problem a little bit better. I'm like, okay, maybe I'm not good at it, but maybe I can try. But look at this, and I'm like, oh well, 25 seconds later, that's not great. So I think here I didn't. I mean, I think I removed the print or something, and I wasn't sure that why I was in printing. And this also takes another long time. And then yeah, I forgot to run it. And it still takes so long. Very sad. Very sad about the pending. Still can't really think about this one yet, even though I'm still looking at it. And I still had to write out the same idea, so it's not like I changed anything. I think it was more of a distraction, which I don't know, probably didn't help as much as I think it would help. But yeah, getting wrong answers. I was trying to figure out why. So I put, and then I was like, oh wait, I need the mod. I remember now. That wasn't it though, because I was like looking at the numbers that didn't really make sense. So I wanted to bring back the print. Still testing, which is a little bit sad. I mean, because it is really silly mistakes, really. And then I look at the output, and I realized that, yeah, I mean, I was just multiplying incorrect numbers, which, which if the test takes 3 seconds, I would have gotten this about 2 minutes earlier or something like that, which is beginning to add up to be a lot of time. Oh my God, this very frustrating. About 2.5 minutes have gone by just from pending tests, which is not great. But luckily, it did work on the first try, first submit, so I finally submitted. That, I mean, I spent about 8 minutes, about 10 minutes on that problem, but about like 3 minutes just testing, so that was really sad. This one, I think I was like, okay, let's do a breadth first search. I think at this point I made a very critical error from the earlier, where I thought I thought the n is 10 to the fifth and not 1,000. And the difference is that if the n is 10 to the fifth, which is 100,000, you cannot do n squared. So I was trying to figure out a way to kind of be clever with breadth first search and stuff like that, and try to be a little bit better about it. But yeah, overall, it spent a good amount of time on this one. I think I knew that what I wanted to do was go backwards, but I was trying to think about different ways of modeling this problem. I mean, it's clearly a graph problem, but a lot of what I spent here, or try to figure out how to do now, is because whatchamacallit, is because I thought n is 100,000, and I was just really trying to like look to see if I've noticed any properties that would make it doable in O of n and so forth. And I didn't really have anything immediate, to be honest. And I think it takes me about, maybe I want to say 10 minutes before I realized that n is 1,000. And then I was like, oh, if it's 10 to 1,000, then we can actually do the graph construction in n squared time, and then if you have that graph, then you can just do the longest path in the DAG very quickly. So that's essentially what I did. But I did spend a lot of time, a lot of time, yeah, a lot of time trying to on wasting. I wasted a lot of time thinking that n is equal to 100,000, and that was kind of the hard part of the problem for me. So I gotta do better about the reading. I guess maybe I'm just not 100% myself today, but that's okay. That's an easy thing to fix in
It's
theory,
1,000.
because that's why I keep on highlighting it, because I was like 100,000. I still don't get it.
Much easier.
But as soon as I realized it was 1,000, it got a lot easier. I'm going to speak a little bit, so you feel free to kind of go for it. But I think I mostly implemented right, and I guess I'll talk about it. I think right now I'm still just trying to stuck on 100,000, but I've been working on this problem for about 4 or 5 minutes without any code. So I was like, okay, let's at least crank out some kind of naive code just to kind of get a sense of what's going on. But I was struggling with this problem a lot because that misreading. Like I didn't know how to start. But now I was like, okay, let's do some kind of breadth first search type thing. Maybe from each thing we could kind of. I think at this point I decided in my head that from each bottom node, there are a couple of what you call it. Like I was thinking about doing at this point, and this is maybe not correct or probably not correct. At least not the way that I constructed or coding it is, and that's what I'm doing the sorting here. Is that I was just trying to figure out the essentially we're like almost like a topological sort kind of thing. Where like okay, we know that we want to start at numbers where or like the lowest number maybe. I was just playing around with that. I wasn't really kind of getting anywhere with it, but yeah, now I feel like yeah, from that I could just start from the bottom and then see how that takes me, where that takes me. And then here I was like, okay, I needed some way of, like if a current index is smaller than the left and the right, then you know that it's going to be a local minima or like an ending point. So let's set those up. And that's essentially what I did here. Unfortunately, I make a typo here that you'll spot in a second, where, to be honest, I just wasn't thinking about it. And a weird thing is that I missed the one test, like I copy and paste all the test cases, and I missed the one test case that would have caught it. But there are 5 test cases, so I don't know. Don't know, I missed it, to be honest. Looking back, I think I was just rushing it a little bit near the end. But yeah, I was like, okay, if this is a breadth first search, then those are the points where like, those are the place you want to end at, right? So that's where that was kind of my logic. And then this is, in theory, what I wanted to do was standard breadth first search. And here I was trying to figure out a way to construct what the next edge is. And the next edge is always going to be the next number that's bigger to this left and then to its right. And I probably need to check in D, but I think at this point I was like, is this going to be too slow? I was like, what if you have like a weird, like, I don't know, but I thought that this may actually get into a case where this is too slow. So I was just trying to think about how to do it a little bit better. Well, it's a little too slow. And also the other thing I realized at this point is that I can't really do breadth first search in this way. Maybe I could if I was very careful about this, but I was worried that I think maybe this would have been okay, to be honest, maybe. But I couldn't prove this to myself. But I worried that it was going to be like O of n in each direction and so forth. But yeah, but I think at this point was when I was like, oh, snaps. N is only 1,000. So I was like in my mind, I was shaking my head, being like, this farm is so much easier. And I was able to do something like this. And then I was like, okay, do I actually need to? Because I think what I was thinking was like, like I think maybe it's okay. I couldn't prove it to myself, but that maybe like there's a way to get to 2 different paths, and then well, what happens when you relax the next node, and how do you make sure that your next node is going to be in the right order and so forth. So I think I was a little bit messy with that. Yeah, and I inverted the graph so that I could go top down. Yeah, that's mostly it. I mean, I think I spent the next 6 minutes. Oh wait, I guess not. Here I'm like, okay, can I just do it with depth first search? I'm thinking right now you could see him keeping dots. And yeah, and then now I'm just doing an index. This is essentially the end of, I mean, like, I actually did everything mostly right here. I think I end up changing the rally, like the what we call like for an index that is smaller than its neighbors. I made that the base case by pre-warming the cache for the dynamic programming cache. But otherwise, it's pretty straightforward. The only thing that I had an issue was that again, and this cost me probably like 40 to 50 prices going from top 100 to about 150 or something like that, which is that I had a typo and also, but that was caught in the test, but somehow I got ready unlucky, lucky slash unlucky where I copy paste all the tests as you'll see, but then I missed the one test that would catch that bug, and then I submitted it, and then I got it back, and then I was like, and then I also that was a really easy fix afterwards. So sometimes, sometimes that's life. But overall, I feel like I did an okay contest. I like Q3 a lot. I like this one a little bit. I think like it just kind of a good refresh of things that I haven't done in a while. And I appreciate that. But yeah, that's all I have. And talk to the other head in about in like 3 4 minutes, or you can fast forward. There's links in the bottom. Anyway, see ya. Oh, the tea. Oh, that was a. Did I? Oh, I missed it. Silly mistake. Oh, this is never true. Oh, this is dumb. Okay. Didn't do well on that one. Yeah, I mean, the second one took me a while. The third one, I think I was just stuck between thinking about different things. And also, I spent a lot of time because I thought n was 100,000 and not 1,000, so I didn't do the n square algorithm. But yeah, we'll go over it. That's two. Where am I? Yeah, yeah, and 5 minutes penalty because I didn't put in a test case because I have a typo. But even with 34, it would have been kind of tight. I mean, it would have been top 100, I guess. So that one silly typo cost me a couple minutes or a couple of ranks. Okay. Need to be a little bit more consistent. But cool, let's go over it. Yeah, probably could have done this one much faster, but I was taking my time just to make sure I read the problem right because I was worried. And also the second one, I had a lot of timing things. I didn't think I took 18 minutes though, but okay. K-week is well in a matrix. I did it in about 2 minutes. Probably a little bit slower, but I think I had I guess I was a little not warmed up, so I had this type syntax error, but otherwise pretty straightforward. You just count number of ones and then you sort by and then you keep the beginning of whatever, the first K elements. Pretty straightforward in theory. Yeah, 103rd, 110th because people are still submitting. And because my 5 limit things is still coming up, I guess. I don't know what time it is now. I guess there's still a couple of minutes, so I'll go down a little bit more. Plus the other server, though maybe that's already factored in. Yeah, so that's pretty much it for the first one. The second one, reduce array size to the half. I took 3 minutes, which felt, I don't know, I felt like it took a little bit longer than I needed to still. I think the big thing is just greedy. You always want to take the max, the number that appears the most. I was trying to do some funky thing, but I was at a typo somewhere. But yeah, just keep on going from the back until you like the biggest element until you see half. I guess I actually didn't end up doing that bad, but it was so slow in the testing today. Maximum swallow. I mean, this one is just dumb. I think I got it pretty quickly. I have to go back to the logs, but my problem was that I just forgot to kind of kick off the. I forgot to do this thing. That's one issue. The second one was that I forgot to use. Well, I used S instead of val, so so I got the wrong thing. So that took a lot of time. But the most time was that I just spent a lot of time waiting for the test to come in because I was just not returning the right thing because of these silly typos. That would have taken me if I had a good computer, it would have probably, or like a good testing environment, it would have probably saved me like 2-3 minutes. So I think that's a little silly. But yeah, in general, what I did was instead of removing an edge, I just did two depth first search. The first step for search is to get the sum of the array, or sorry, the sum of the tree. And the second one is just to be like, okay, if we cut out the parent of this node, what is the maximal? If we cut like this gets the sum of the subtree, and then from the sum of the entire tree minus the sum of the subtree, then you could just do the math on multiplying and getting the best. That's essentially what I did. Yeah, pretty okay, I think. I mean, this should not have taken 10 minutes. I don't know how long I should have taken, but a lot of it was spent on just waiting for the test to finish. And then maybe I need to do stuff locally so that that doesn't happen. Because if you saw it, so if you watched it live, it took a while because of that reason. This one, I think I just really I thought it was gonna be more breadth first search, but then it ended up being or I just didn't really connect stuff together. So basically, it ended up being longest path in a DAG literally. So what I did was I reconstructed the DAG And then that's it. We consider DAG and then dynamic programming to get the longest path. I think I was really, I mean, I spent time to type out all these examples, and then I missed example 3, I suppose, which caused me to fail and give a wrong answer. And that wrong answer was just because I had a type. I didn't even copy and paste. I typed it out. I think I was just not thinking really, because I was rushing this part a little bit. And that's pretty much it. The longest path in the DAG really should not have taken me 18 minutes, but I spent, I don't know how long I spent, but I spent a good amount of time thinking that the array length is 100,000. So the reason why that's relevant is because I was trying to think about some linear time algorithm. That's why I was leaning towards some sort of breadth first search, because because I think there's only at most 2 paths and so forth like that. So there is probably a linear one. Linear algorithm of dynamic programming somehow. But later on, I noticed that it was n equals or n is up to 1,000. So then the ordering is not as sensitive, or like the timing on the running time is not as sensitive. So I could get away with n square, and that's essentially what I end up doing. I think. To be honest, it might not. Mine still might be linear-ish, but that changed my philosophy, and like I could be a little bit looser on my bounds, and that enabled me to solve it much quicker. That was just a silly misreading, and also just silly mistake or silly typo here, and not like I took the time to test case it, but I missed one test case because there's so much. I still advocate that Leetcode should have a easy like just put it all, like why only one? Just give us all 5. Like everyone's doing it really, so everyone's saving the same amount of time. But yeah, so that's all I have for this problem. Finished probably about like I don't know. Ooh, if 135th. I thought it was gonna drop, but maybe not that low. But it is what it is. Yeah. So overall, not a super good contest. I think still battling a little bit of sickness, but that's an excuse. I have the capacity to do a little bit better, so I think that's always, I mean, that's okay. I'll kind of, figure out how to do a little. I mean, there's just a lot of silly mistakes, and both on, and maybe I really need to at this time set up the internal testing so that what happened in Q3 didn't happen more often because it was just taking so long. But yeah, anyway. I feel like I learned a bit. That was fun, and yeah. I mean, I definitely thought that Q3 was a good problem. To be honest, it took me a little bit to get around to thinking about it in a different way. It's just that I spent too long debugging because both the server was slow and I was being dumb in a number of places. Anyway, see you next week. Thank you for watching. Hit the like button, hit the subscribe button, and yeah, see you again next week. Bye bye.